Ever wondered what exactly Pythonic code means? If so, you're in the right place. When we talk about Pythonic code, we're referring to code that not only runs correctly, but also adheres to Python's idiomatic conventions and philosophy of simplicity and readability. You see, Python, the programming language, was designed with a clear philosophy in mind, captured eloquently in the Zen of Python. This is a collection of 20 guiding principles that serve as a compass when writing Python code. It places a strong emphasis on code readability and simplicity, and it's these principles that define what we mean by Pythonic. Now, why is Pythonic code so important? Well, three primary reasons come to mind: readability, maintainability, and performance. Let's break these down. Firstly, readability. Pythonic code is easy to read and understand. This is crucial because code is read much more often than it's written. Python's clean syntax and use of white space make it inherently readable, but following Pythonic principles takes this a step further. Next, maintainability. Pythonic code is easier to maintain and update. By sticking to conventions and idiomatic patterns, you make it easier for others, and your future self, to dive into the code, understand what's going on, and make necessary modifications. And lastly, performance. Pythonic code often translates into efficient code. Python's built-in functions and constructs are optimized for performance, so using them where appropriate can lead to speed gains in your programs. But perhaps one of the most compelling facets of Pythonic code is how it sets Python apart from other languages. Python's emphasis on simplicity, readability, and one right way to do things contrasts with languages that offer multiple ways to achieve the same result. This unique aspect of Python is often what draws developers to the language and keeps them engaged. Indeed, understanding Pythonic principles is the first step to writing clean and efficient Python code. It's not just about making code work, it's about making it work well in a way that respects Python's philosophy and leverages its strengths. So let's continue this journey and delve deeper into the world of Pythonic code. So, how can you ensure your Python code is both clean and efficient? Let's dive into some key best practices that can elevate your coding skills to the next level. Firstly, variable naming conventions play a crucial role in enhancing code readability. Names should be descriptive and meaningful, accurately reflecting the purpose of the variable. For instance, instead of using X for a list of customer names, customer_names would be a far more informative choice. This clarity helps others understand your code more easily. And even your future self will thank you when revisiting the code weeks or months down the line. Next, let's talk about code formatting. Python has a style guide known as PEP 8, which provides guidelines for formatting your Python code. Following PEP 8 not only makes your code more readable, but also ensures consistency across your code base. This includes rules like using 4 spaces for indentation, limiting line length to 79 characters, and placing imports at the top of the file. While these might seem like minute details, adhering to these guidelines can significantly improve the cleanliness and readability of your code. Now on to the art of commenting. Comments are like breadcrumbs left behind for those who venture into your code. They provide context and explanation for your coding decisions. However, remember that comments should be meaningful and concise. Rather than stating what the code is doing, comments should explain why it does so, especially when the logic isn't immediately apparent. We also can't overlook the importance of organizing your code logically. Breaking your code into functions and modules not only makes it more manageable, but also promotes code reuse. Functions should perform a single, well-defined task, and modules should group related functions together. This modular approach makes your code easier to understand, test, and maintain. Let's not forget about error handling. Using try-except blocks to catch and handle exceptions can prevent your program from crashing unexpectedly. It's also good practice to log errors for future debugging. This way, even if something goes wrong, your code fails gracefully, providing valuable information on what caused the issue. Finally, testing is an integral part of writing clean and efficient code. Regular testing helps you catch and fix bugs early, before they escalate into bigger issues. Unit tests, for instance, check individual components of your code to ensure they work as expected. By integrating testing into your development process, you can maintain high code quality and prevent potential issues from slipping through the cracks. By adopting these best practices, you pave the way for a clean and structured code base. Remember, the goal isn't just to write code that works. It's to write code that's easy to read, understand, and maintain. So, whether you're working on a small project or contributing to a large code base, these practices will serve as your guiding principles, helping you write Pythonic code that truly stands out. Are you aware of the Pythonic constructs that can make your code more streamlined? Python is renowned for its simplicity and expressiveness, and much of this reputation is due to its unique constructs that allow you to write clean, efficient code with minimal effort. Let's delve into these Pythonic constructs and see how they can enhance your coding prowess. First off, let's talk about list comprehensions. These are a Pythonic way to create lists based on existing lists or other iterable objects. They are concise, readable, and faster than traditional loops. For example, a list comprehension can generate a list of squares for the first 10 natural numbers in a single readable line of code. This not only makes your code cleaner, but also boosts its performance. Next, we have generator expressions. These are similar to list comprehensions, but instead of creating a list, they create a generator object. The key benefit of generator expressions is that they are lazy. They generate values on the fly, one at a time, only when you request them. This makes them incredibly memory efficient, especially when dealing with large amounts of data. Now let's move on to context managers. These are Pythonic constructs that manage resources for you. They ensure that resources are properly acquired and released, even if errors occur within the block of code. The with keyword is used to create a context manager. This is most commonly used when working with files, but it can also be used with other resources like network connections or database transactions. Using context managers can greatly simplify your code and make it more robust. Then we have Python's built-in functions like map, filter, and reduce. These functions can perform operations on lists or other iterable objects in a highly Pythonic way. The map function applies a function to each item in an iterable. The filter function filters items out of an iterable. The reduce function, on the other hand, applies a function of 2 arguments cumulatively to the items of an iterable. Using these functions can make your code more readable and expressive, and they often outperform equivalent code written with loops. It's important to note that these Pythonic constructs aren't just about making your code look pretty. They genuinely enhance the performance of your code. List comprehensions and built-in functions like map and filter are faster than equivalent code written with loops. Generator expressions are more memory efficient than lists. Context managers ensure that resources are handled efficiently and safely. So, how do you start leveraging these Pythonic constructs in your code? The answer is practice. Start by rewriting some of your existing code using these constructs. Replace loops with list comprehensions or built-in functions. Replace lists with generator expressions where appropriate. Use context managers when working with resources. As you gain more experience and confidence, you'll find yourself naturally writing more Pythonic code. Remember, the goal isn't just to write code that works, it's to write code that is clean, efficient, and Pythonic. This not only makes your code easier to read and maintain, but also improves its performance. And that's what Pythonic coding is all about. Leveraging these Pythonic constructs can truly elevate your code, making it more expressive and efficient. So embrace these constructs, practice them, and watch your Python skills soar to new heights. But what about the performance of your Python programs? How can you optimize it? Efficiency isn't just about writing code that works. It's about writing code that works well. And when we talk about performance, we're talking about how quickly and effectively your code executes. This is where the art of optimization comes into play. One of the first steps to optimizing your code is to choose the right data structures. Python provides a variety of built-in data structures, each with its own strengths and use cases. Lists are great, but sometimes a dictionary or a set might be more efficient, especially when you need to store unique items or perform quick lookups. An optimized code also knows how to avoid unnecessary loops. Loops are great for repetitive tasks, but they can also slow down your code, especially when dealing with large data sets. So, instead of using a loop, consider using Python's built-in functions or list comprehensions. They're not just more Pythonic, they're often more efficient too. But what if you could avoid doing certain computations altogether? That's where memoization comes in. Memoization is a technique where you store the results of expensive function calls and reuse them when the same inputs occur again. This can drastically speed up programs with many repeated calls for the same inputs, like in dynamic programming. Python's built-in functools module provides a decorator that enables automatic memoization and caching. Algorithmic optimizations are another aspect of efficient programming. This involves choosing the best algorithm for the task at hand. A simple example is sorting a list. Python's built-in method uses a sophisticated algorithm called timsort, which is incredibly fast for nearly sorted lists. But if you know your list is almost sorted, you could implement an insertion sort algorithm, which could be faster in this specific scenario. Finally, Python offers profiling tools, like the module, that can help you identify bottlenecks in your code. Profiling essentially means measuring the performance of your code's execution. It provides a detailed breakdown of where your code spends its time and which functions are called most often. By using a profiler, you can focus your optimization efforts where they will make the most difference. So you see, optimizing Python code isn't about making tiny micro-optimizations. It's about understanding your code, your data, and the problem you're solving. It's about making smart decisions and using the right tools and techniques. Remember, efficient code isn't just about doing things right, it's about doing things smart. And the more you code, the more you will understand this subtle art of optimization. So keep coding, keep learning, and most importantly, keep optimizing. Congratulations! You've journeyed through the landscape of Pythonic coding. We've traversed through the intricacies of Python's philosophy, adopted best practices, leveraged Pythonic constructs, and even delved into the art of optimizing performance. Let's take a moment to revisit our journey and cement these key points in our coding arsenal. We began by understanding the concept of Pythonic code. It's not just about writing code that works, it's about aligning with Python's philosophy and idiomatic conventions. We learned that Pythonic code is paramount for readability, maintainability, and performance. It's an art that sets Python apart from other programming languages. Remember, Pythonic code is clean, efficient, and a joy to read. It's poetry in code form. Next, we embraced the best practices for writing Pythonic code. We discovered the importance of clear variable naming conventions, how to format code according to PEP8 guidelines, the significance of meaningful comments, and the art of organizing code into logical functions and modules. These practices are not mere rules but guiding principles that enhance the clarity and structure of your code base. By adhering to these practices, we're not just writing code, we're crafting masterpieces. Then, we explored various Pythonic constructs. We learned about list comprehensions, generator expressions, context managers, and the use of built-in functions like map, filter, and reduce. These constructs are not just tools but powerful allies that simplify complex tasks and improve the performance of your code. They're the secret ingredients that make Pythonic code both expressive and efficient. Finally, we delved into the realm of performance optimization. We discovered the magic of efficient data structures like dictionaries and sets, the art of avoiding unnecessary loops, and the power of techniques like memoization and algorithmic optimizations. These strategies ensure that your code runs smoothly and efficiently, even when grappling with large datasets or computationally intensive tasks. They're the fuel that drives Pythonic code at breakneck speeds. In essence, writing Pythonic code is like preparing a gourmet meal. Every ingredient, every technique, and every presentation detail counts. The principles, practices, constructs, and optimization techniques we've discussed are the ingredients and techniques of your Pythonic gourmet meal. So go ahead, embrace them, experiment with them, and create your own Pythonic masterpiece. Remember, the journey doesn't end here. The world of Python is vast and ever-evolving. There's always something new to learn, a new technique to master, or a new construct to explore. So keep honing your skills, keep experimenting, keep refining, keep honing your skills, and soon you'll find writing clean and efficient Python code second nature. Until next time, happy coding.